some of those at home. I'm doing lots of arm motions today. You can visually imagine what that looks like, but that's the best you're going to get. Here we go. We are graphing some different things. I think it's really important when you graph to not only understand what the shape looks like, but how we get it, okay? I also really believe in memorization of this a little bit as well, okay? And that's not always your favorite thing to do. It is going to make your life so much easier when you just memorize this stuff, and that's where I'm going to try to get to today, all right? So we're going to go through these different shapes. I'm going to show you how we get them, but also how to do them quickly. That's going to be our main goal, all right? So for graph number 1, we are graphing a constant graph. It says f of x equals b. What does f of x mean? Y. Pick your favorite number between -6 and 6. Somebody say it out loud. 3 was the first and loudest. So we're doing y equals 3. You got to be quicker next time. Show me with your arm, what does y equals 3 look like? If it is a y equals line, it is going to cross the y-axis. And so we're going to go to where y equals 3, and we're going to draw a horizontal line. So y equals is a horizontal line. Let's say I gave you like x equals 4. What would x equals 4 look like? That is a vertical line. We're not going to do a lot of x equals 4 because this is all about functions. And it's a function. So that's not something we'll do all the time, but I just wanted you to see it to make sure you know. Okay, so constant lines, we can do that. Not a whole lot necessary there. Next one is linear, okay, or an identity function is what y equals x is sometimes called. The identity function. Show me your arm. What do you think y equals x looks like? Good. Y equals x. It's got a y and an x. It's not just x equals or y equals. It is y equals x. It is in the form y equals mx plus b. What's my slope? My slope is 1. What's my y-intercept? 0. So I'm just graphing this line. I'm starting at 0. My slope is 1. Up, 1 over 1, up, 1 over 1, up, 1 over 1, and so on. There's my graph. That is a linear function. Okay, just a slanted line. It's the most basic version we got. Questions there? Quadratic. Okay, y equals x squared. Show me with your arms. What do you think that one looks like? Okay, so we get to our first issue. Some of you think you're cool and do this, or just like hold your arms like this. We are all nerdy in here together. Okay, we're all going to look dumb at the same time. So if I ask you what does it look like, you're going to get big and bold and show me with your arms what does it look like. So we hold our arm. Oh, no, see, that's not good enough. Up, up, yeah. We look dumb together. And I'm going to wait. See how Sam didn't do it? Let's do it again. Everybody show me with your arms. There we go. Wonderful. We are all in this together. We will all look ridiculous at the same time. That's what I like. F of x equals x squared. We are graphing this thing. Okay? You could what you did back in like 7th grade and do some t-charts. Okay? But I'm going to have you memorize them. Let's start off by doing a t-chart. What's a good number to plug in? 0. If I plug in 0 and square it, I get 0. If I plug in 1 and square it, I get 1. 2 gets me 4. 3 gets me 9. I really don't want to plug in 4 because I get 16 and I can't graph that thing. But you go on that side? Here's the right. Can I do to the left? Yeah, what's -1 squared? 1. -2 squared is 4. -3 squared is 9. Whee. There's the left side. Sound effects are important when graphing. There's my graph. The nickname, there's no fun nickname here. We already know what the shape is called. This is a parabola. The shortcut, and I think this is really important because we're going to graph these things all the time. You can do what we just did, plug in numbers, but it's not real fast, especially start moving it and shifting it and doing a whole lot of others. Okay, and so when we graphed this thing, we started at the vertex. We went up 1 and over 1 and made a dot. Then we went up 3 and over 1. We're doing it both ways. Up 3 and over 1, and then we went up 5 and over 1. Okay, so my pattern for a parabola, when we graph it, is 1, 3, 5. Okay, 1, 3, 5. Up 1, over 1, up 3, over 1, up 5, over 1. It's the quickest way to graph it. We're going to graph this thing so often, you want to be good at it and do it quickly. That's going to be a pattern that helps us get there. Domain. What do you think the domain is going to be on a parabola? The domain is all real numbers because I can plug in any number I want and I can square. It's not a fraction. It's not a root. We're good. It's all real numbers. range here. Greater than or equal to 0. So I'm going to go from 0. That's infinity, I swear. 0 to infinity. Show me with your fingers on that graph right there. Even, odd, or neither. Even, odd, or neither. It is even. It is an even graph. It has y-axis symmetry, so I could fold that right in half. Questions with parabolas? Should be good at that one. The other one we should be good at, hopefully, is absolute value. Show me with your arms. What does absolute value look like? Yeah, Sophia was trying to be here, and then she realized I wasn't going to cut it. Sam. Thank you, Sam. Absolute value with a V. Okay, it's got a V in it. It's going to tell me exactly what the name of the shape is. It's absolute value with a V. Okay, my nickname is a V shape. It's a very original nickname here, but it's a V shape. To graph it, you just go up 1 over 1. Both directions. Okay, it's just a real simple slanted line. Up 1 over 1, up 1 over 1, up 1 over 1, and so on. It's the easiest one to graph. Absolute value. Because if I plugged in 1, it'd be 1. If I plugged in 2, it'd be 2. And when I plug in the negative version, it would go positive as well. That's what makes me that shape real quick. These aren't just make-believe numbers. Domain? All real numbers. Range? 0 to infinity again. It's staying above. There's not any negative y values, because when you square something, it can't be negative. When you take the absolute value of something, it can't be negative. That's why we're only going from 0 on. 0 to infinity. Show me with your fingers, even, odd, or neither. Even, odd, or neither. We're getting some evens, because you can take that thing and fold it over the y-axis. That's what even symmetry means. Yeah. Oh, yeah, we got, all right, new learners here. Megan, 2 is, because it's even. You can show me 4 if you want to get crazy, but it's pretty crazy. Even means you can fold it over the y-axis. Odd means origin symmetry. You got that? Are you listening? You haven't watched that video yet, have you? That was Wednesday. So then no. Okay, fine. Cubic functions. X cubed. Let's plug in some numbers. What's a good number to plug in here? 0. Let's plug in 0. When I plug in 0, I get 0. Then I could plug in 1 would get me 1. Then plug in 2 gets me 8. 2, 8. I plug in 3, I get 27. I'm way off the page. I don't want to go any further than that, but 3 would get me 27. Okay, so on the right side, I do one of these right here where I really just take off really quickly after I've done that. That's the right side. On the left side, if I plug in -1, what am I going to get? -1 is going to get me -1. If I plug in -2, I get -8. So on the left side here, it's the same as the right, only I'm going down this time. Show me with your arms. What's that shape? Wonderful. It goes like that. Okay? It goes down like that. So my best nickname for this is called a broken parabola. Why is it a broken parabola? Because this is what a parabola looks like. To make this shape, break your arm down. Okay, the arm goes down instead. These are dumb nicknames. Okay, they are not for any other reason for me to quickly say this dumb nickname and you know what the shape is without me saying x cubed. Because I want you to say, oh, it's x cubed. What does that shape look like? If I call it a cubic function, then you're not really getting the same thing, and I want you to be able to go back and forth. The dumb nicknames are just for us and no one else. If you go to college and you're like, oh, that's the broken parabola, they're gonna be like, oh, you're dumb. Okay, don't do that. These are just for us. Shortcuts. When we graph this thing, okay, to get this, we are going up 1, over 1 for that first one. Then I'm going up 1, 2, 3, 4, 5, 6, 7 over 1. Okay, so with a cubic function, my pattern is 1, 7. Up 1, over 1, up 7, over 1. Everybody good there? Domain. Domain is all real numbers. I can plug in any number. I can plug in 5, and it's going to be 125, but I can plug it in. I can plug in 10 billion. It's going to be huge, but I can plug it in. What about range? All real numbers, because this time I got an arrow pointed up to the ceiling and down to the ground. Okay, I got to go in both directions, so I'm all real numbers. Show me with your fingers. Even, odd, or neither. Even, odd, or neither. Yeah, you can just hold up the number 1 if you want, but it's odd. Okay, it has origin symmetry. If I were to take this graph and flip it up and over, it would match up. Questions on that one? Square root. If we're graphing the square, what's a good number to plug in? Can you take the square root of 0? Yeah, kids always hesitate though. You can take the square root of 0. Square root of 0 is 0. Then I should plug in 1. If I plug in 1, I get 1. What should I plug in next? 4, because nobody wants to graph square root of 2. That's no fun. Go to 4, I get 2. The next thing I should plug in is 9, because the square root of 9 is 3. On the right side, we get a shape that looks like that. What about on the left side? What do we plug in over here on the left side? Nothing. Why can't I plug in anything over here on the left side? Correct. It's not a rhino. He's a unicorn that eats a lot. Be nice to him. He's imaginary. We can't put anything on the left side. Oh, yeah, the rhino really threw us off. I need to go longer legs, a little more majestic here. Is that better now? I mean, just a flowing. Oh, that's so much better. Totally know what we're doing now. That totally makes sense. It's imaginary. Shh, don't make fun of me. We graph it to the left. You can't go to the left because if I take the square root of a negative number, it'd be imaginary. Nickname. Show me with your arm. What's that shape? All right. So some of you are doing it correctly. Some of you are like, that's too much. It's too much work. We just go arm to the side. Okay. This is this graph right here. And if any other, I hate this. Math teachers steal this from me all the time because it's wonderful. Okay. But when I first did this, I do these arms all the time. And I put my arm like this, and I just automatically went like this at the same time. Okay, and I started singing to myself, I'm a little teapot, short and stout. Here is my handle. There is my spout. It's perfect. You did it exactly how I want you to do it. That right there. Okay, that's the teapot of our graph here. So my nickname is the teapot graph. It's very adorable. It's a teapot graph. It's dumb, but it helps me remember. Okay, the one thing I always think about as well is the square root sign. Look at the square root sign. It looks like the root that we just made, right? It's the same general shape. So when I think, oh, it's a square root, it's going to make that same shape to help me out. It is a square root. So like a squared function, like a parabola, my pattern is very similar. To get to this dot, I got to go up, over, and up 1. I'm going up 1 over 3. Then I'm up 1 over 5. So it's that same 1, 3, 5 pattern. But obviously, it's a little bit different because I'm going over 135 instead of up 135. Okay, so we're up 1 over 1. Up 1 over 3. Up 1 over 5. Take a second with your neighbor. Do domain, range, even or odd real quick. Here we go. We do not have a lot of time today. Let's keep going. Ella, what do you say for domain here? Wonderful. 0 to infinity. Bracket on 0 because we can take the square root of 0, but we can't go any negatives. Aaron, C, what do you say for range?
I said bracket 0 infinity.
Yep. Same thing as range because we're starting at 0. We can go above 0, but we can't get negatives when we take a square root. Even, odd, or neither. Show me with your fingers. Even, odd, or neither. It is neither. So it is neither. It does not origin symmetry. You can make a bird here to show me neither. But remember, opposite quadrants don't look the same. Okay, here I've got this teapot graph. In the third quadrant, the opposite one, there's a rhinoceros. They're not the same. Have I told you about sea turtles yet? No. Okay, so birds are fine, and I like birds. But I had a student always that gave me a sea turtle, and it made me really happy inside. So if you want to drop a sea turtle on me, I'm good with that. Let's go backside. Keep with me. Cube root graph. Cube root. Let's start off with 0. If I plug in 0, I get 0. What else can I take the cube root of? 1. If I take the cube root of 1, I get 1. Then I'll take the cube root of 8. The cube root of 8 would be 2. So on the right side, I'm getting this graph right there. Can I go to the left? Yep. Cube root of -1 is -1. the cube root of -8 is -2. So I get that shape right there. Show me with your arms. What does that look like? Yeah, that's this thing right here. Some teachers call that thing right there the S curve, and it doesn't make any sense. That's not an S curve. This is an S curve. It looks like an S a little bit. Okay, so an S curve shape. Some students call it the Egyptian graph because you do kind of the Egyptian dancing arm thing that you're doing. Whatever makes you feel happy inside, do that. Okay, I'm gonna go with S curve for me. Okay, shortcut. It's a cube root. So what was our pattern for a cube graph? 1, 7. So my shortcut for this one is also 1, 7. Okay, it's also going to be 1, 7 because again, I'm using the same idea. I'm going up 1 over 1 and then up 1 over 7. Domain, what's my domain going to be? All real numbers. Range, what's my range going to be? All real numbers. Show me with your fingers. Even, odd, or neither. Even, odd, or neither is odd. Opposite quadrants look similar. Is odd. Got to keep going. I don't know how I slowed down so much. Probably that rhinoceros. Reciprocal. 1 over x. What's a good number to plug in here for 1 over x? Why didn't you pick 0? Let's plug in 0. We plugged in 0 every other time. What happens when I plug in 0? Undefined. Okay? Undefined means I cannot graph it. In fact, when you get undefined, like 1 over 0, you're going to get a vertical asymptote. So that's a really important aspect to this graph. I'm going to draw a vertical dashed line here, okay, at the y-axis because there is an asymptote line going there. It is undefined at that spot. I can't graph anything there. And so I want to signal to myself that, hey, I can't put anything there. I cannot cross a vertical asymptote. That's all bad. Okay, we get really close to them, but we do not cross a vertical asymptote line. Got that? What should we plug in next? 1. If I plug in 1, I get 1. Then what? 2. If I plug in 2, I get a half. Then I should plug in 3. If I plug in 3, I get a third. I plug in 4, I get a fourth. I plug in 5, I get a fifth. What can I plug in to get me 0? Nothing, because even if you went to a bajillion, it'd be 1 over a bajillion, and it would be just above the y-axis. Okay, so as I work to the right here, I get really close, but I don't touch it. It's because there's a horizontal asymptote at y equals 0. You technically can cross horizontal asymptotes, but we don't cross this one. Okay, there are some that we cross. This is not one of them. But that's not really giving me the full picture, because what happened in between these two spots? What's a number between 0 and 1, like a half? What would I get if I plugged in a half? 2, because you would go 1 over a half, or the reciprocal of a half, you would get 2. And if I plugged in a third, I'd get 3, and so on. So what's going to happen is I'm going to get really close to that y-axis, but I'm not going to touch it. And I'm going to get that graph right there. Let's plug in a negative number. So negative number I could plug in here is -1. If I plug in -1, I'm going to get -1. And I'm going to get the exact same shape here, but now I'm going to be down here in quadrant 3. It's going to get me that graph right there. Show me with your arms. What does that thing look like? It is hard to do. So you got one arm, and you kind of got to bend it here in the first quadrant, and then you got another arm in the third quadrant. But if you do it like this, it doesn't really look right, so I always got to kind of lean a little bit. Yeah, so look how cool you guys look right now. And I did this for the first time, and I put my arm here, and I put my other arm here, and I felt real smooth with it. And I had to get just a real smooth walk going on. So that's what I did. All right. If you see someone in this class and you're walking down the hallway, it looks like they're having a bad day, you just give them a head nod and one of these, they're going to have a better day. I guarantee it. There is no way they're going to have a worse day after you did that to them. Okay? So, not a great name. This is just called a reciprocal graph. But I'll refer to it as the cool kid. Because you are being the cool kid when you throw those up and walk down the hallway. Brighten someone's day. Shortcut. I don't have a great shortcut here. I'm just going to say hug the axis. Really, the only 2 dots that you have to touch are those first 2, and then do the best you can. All in between there. We're not going to get too crazy. I'm running out of time, so I'm going to do domain and range quickly. Domain, all real numbers, but what? X isn't 0. My range is going to be all real numbers, but Y cannot be 0 because it's range. Show me with your fingers, even, odd, or neither. It's odd. It's got origin symmetry. Last one, okay? The integer function, okay? The greatest integer function. Sometimes it can be as the floor, okay? The floor graph. And like if you did this on Desmos, you use floor to graph it. It's weird, okay? So it's got these two brackets, or it could say int, or it could say floor. All three of them can give you the same thing. Okay? What this thing does is if you plug in an x value, it is going to round down to the nearest integer. Okay, round down to the nearest integer. For example, if I plug in 0, I'm going to get 0. If I plug in 0.5, what am I going to get? 0. If I plug in 0.999, what am I going to get? 0. What happens when I plug in 1? I get up to 1. So I'm here, I'm a straight line until I get to 1. If I plug in 1.5, I'd be here all the way up until 2. It'd be a straight line, and then it would jump to 2. Okay. In fact, you could probably draw an open circle there on the end of that line because it's all the way right up to it and then not including. All the way right into it, not including. All the way not into it, not including. If I plugged in negative 0.5, it would round down to negative 1. Okay, so draw these negative ones in as well. I get that right there. Show my arms. What's that look like? I just do this. Just do steps. Just do steps. My name for this thing? Steps. Shortcut. Draw steps. Domain. All real numbers. Range. Correct. It is one of the letters. Is it all real numbers? No, because I can't get a y value of 0.5. There is nothing on my graph at 0.5. You guys are just throwing out letters? We're just going to say the alphabet. Is all integers. And think about the numbers we got. We got negative 1. We got negative 2. We got 0, 1, 2, 3, 4. It's just integers. So we use the letter Z to represent integers. More than remembering that it's the letter Z, I'd rather just remember, oh, it's integers is that I'm trying to get here. Even, careful with this one. Even, odd, or neither. Show me with your fingers. Even, odd, or neither here. It is neither. Okay? And that's hard to see. A lot of you probably think it looks odd. It is not. Just think about this line right here between 1 and 2. If I were to take it and flip it over here, it'd be right here. And then I'd flip it down. It should match up right there, but it does not. And so this is a neither graph. It looks close for those at home. I just took this thing right here. I folded it over. It should be right here. And then I folded it again. It should be right there, but it's not. Okay. So it does not work like I want it to. So it is a neither graph. Questions?